Problem 15 from OPENSTAX asks us to calculate the molar mass, remember that has units of grams per mole, for some various organic molecules. So again, you use the average atomic masses found on your periodic table. I like to use those found on ptable.com. And so let's go ahead and jump into it. So watch out for the subscripts and look for carbon anywhere in your formula. This is not a carbon, that's a chlorine atom. So Cl is chlorine. It looks like that L is a capital I or a different element, iodine, but actually it's a Cl, a carbon, capital C, lowercase l. So anyways, we have 2 carbons, and the average atomic mass of carbon is 12.011, so we multiply that by 2. The next element up for bat is the hydrogen atom. We have 1 of those. The next element is bromine. Bromine is element number 35. It's in the halogens, and it has an average atomic mass of 79.904. Next is chlorine. Okay, and the last is fluorine. So we have 3 of those fluorines. Fluorine is, again, in the halogens. It has 18.998 as the listed atomic mass. So 3 times 18.998 is 56.994. Now we want to add these all up to get the total. And the grand total here is 197 and some change. So this is the molar mass of this organic compound. Okay. Here's another organic compound, paraquat. So this guy here has 12 carbons. It's got 14 hydrogens. Okay, it's got 2 nitrogens. So you got to find all these elements on your periodic table. And we're multiplying them by the subscripts. And remember, if there's no subscript found, the subscript is assumed to be 1. We've got 2 chlorines. Now I just want to mention again that Cl is chlorine. It's not carbon, so that's not carbon. Okay. If you did have C capital I, it would be in a font that looked like that. That would be carbon and iodine. So that's just a side note there. So 70.9. Now let's go ahead and remember the last step is to always add all these up. And let's see what we get for the grand total for the molar mass. Okay, so the grand total here is 257.158 grams per mole. Okay. Caffeine. All right, so 8 carbons, 10 hydrogens, 4 nitrogens, 2 oxygens. Quite a handful there. So let's go ahead and compute the molar mass here. So we have 8 carbons. Each of them has an average atomic mass of 12.011. So we multiply all the subscripts by their masses that we find in the periodic table. I like to use the periodic table found on ptable.com. Okay. So 4 nitrogens are in this formula. Each nitrogen has a mass of 14.007 grams per mole. And so 4 times 14.007 is 56.028. And we keep repeating this procedure for all of the elements in our substance. And so the last step is to add all of these up. So let's go ahead and do that. And this will be the answer that we are looking for. Okay, so I'm getting 194.194 grams per mole. So there you go for caffeine. D is urea. And we need to watch out for a couple things here. So if you see something like this, that's cobalt. Okay, if you see something like this, that's carbon and oxygen, or maybe carbon monoxide, right? So that's carbon, and that's oxygen. And the other thing you have to watch out for are the parentheses, but we'll get to that later. So we have one carbon, which has an average atomic mass of 12.011. We have one oxygen. This is outside the parentheses, so we don't need to really think about this right now. Now, when we think about the nitrogen, we need to think carefully about the parentheses. Okay, there's a 1 not shown for the subscript of nitrogen, and there's a 2 outside the parentheses. So there's a total of 2 nitrogens in this formula. Okay. The hydrogen atom, oh, I don't want to use green. The hydrogen atom, there's 2 in this NH2 portion because there's a coefficient of 2, but then we have 2 of those. So remember, the parentheses means, and a subscript outside the parentheses means you have 2 of whatever is inside the parentheses. So we have a total of 4 hydrogens here. So we need to take that into consideration carefully when we're computing our average, our molar mass. So 4.032 is what we get there. And the final step is always to add up the total contribution of masses from all your different elements. So let's see what we get, and this will give us the final desired answer for this problem. I'm getting 60.056. And those are units grams per mole. Okay. Part E. We've got a typical soap, they say. So I guess a typical soap is pretty big molecule. So we got 17 carbons. We have 35 hydrogens. And we have 1 carbon and 2 oxygens and 1 sodium. Okay. So remember again that capital C, capital O is carbon and oxygen. And remember that capital C, lowercase o is cobalt. Okay, that is not in soap. And your capital N, small a is, your typical sodium. It's not nitrogen. All right, so let's go ahead and do this. So we have 17 carbons. Each carbon has an average atomic mass of 12.011. So we multiply that out, and this will be the contribution of the molar mass from carbon. And we repeat this process for the different elements. So 35 hydrogens in this formula. Each hydrogen has a mass of 1.008. giving us 35.28. Carbon, oh, I did forget to just add that in there, didn't I? Normally I would make that 18. It's okay. We'll just go ahead and add this in here. It would have been better if I just made that 18, but that's fine. We have 2 oxygens. We have 1 sodium, and sodium is element 11 in your periodic table. And you should have a molar mass something like that. The last step, remember, is always to add them all up. Okay. And the molar mass of our typical soap here is 306.466 grams per mole. Okay, now I'm done with the video, and thanks for watching, and as always, please consider subscribing.